Can you win any casino game using just math and formulas? If you go from books to casinos, you find people like Einstein or Newton, their excitement palpable and eyes fixed on the roulette wheel as it spins again and again. But they don't rely on luck. They're scientists, and they have a secret weapon: science. While the crowd bets blindly, trusting in chance, these brilliant minds see patterns where others don't. The house might have the statistical edge, but they have something more powerful: a deep understanding of the mechanics behind the game. This is the story of how brilliant minds took on the house edge, using nothing but science to beat the odds at roulette. You see, the game of roulette has long been a symbol of chance. The spinning wheel, the bouncing ball, the anticipation as it finally comes to rest on a number. It all seems so random, doesn't it? But here's the thing: in the world of physics, true randomness is a rare thing. Most phenomena, even those that appear random at first glance, follow predictable patterns if you know where to look. So, this is where our story begins, with a simple yet profound realization. Roulette, at its core, is a physical system governed by the laws of motion. And if it's governed by physics, then maybe, just maybe, it could be predicted. Our first protagonists are Albert Hibbs and Roy Walford, two students from the University of Chicago in the late 1940s. Hibbs, a mathematics graduate student, and Walford, a student, decided to take a break from their studies and embark on the mission of beating the casinos at their own game. Their arms were just their knowledge of mathematics and physics, and with that, Hibbs and Walford hopped on their motorcycles and headed to Reno, Nevada, the only state where gambling was legal at the time. The first step of their plan was to study the roulette wheels and look for weaknesses they could exploit. But wait a minute. Isn't roulette supposed to be completely random? Well, let me tell you something. You see, the roulette wheels of the 1940s weren't as sophisticated as the ones we have today. They often had mechanical defects, tiny imperfections that most people wouldn't notice, but that could make a big difference in where the ball landed. So, Hibbs and Walford spent hours observing different roulette wheels, meticulously noting their behavior. They weren't looking for a way to predict the exact number where the ball would land. That would be impossible. Instead, they were searching for patterns, biases in the wheels that would make certain outcomes more likely than others. And guess what? They found them. By carefully studying the idiosyncrasies of various machines, Hibbs and Walford developed predictive models. They weren't perfect, obviously, but they gave the duo an edge, a way to tip the odds in their favor. Armed with this knowledge, they placed their bets strategically and managed to win thousands of dollars. And everybody noticed. In December 1949, Life magazine ran a feature story on their exploits and catapulted them into the spotlight. Hibbs and Walford were open about their methods, probably figuring that their moment in the sun would be short-lived. And they were right. The casinos, not surprisingly, weren't thrilled about a couple of college kids outsmarting their systems. They quickly began upgrading their equipment, replacing the biased wheels with smoother, more reliable ones. The era of exploiting mechanical flaws in roulette wheels was coming to an end. But really, this was just the beginning of our story. The gauntlet had been thrown down, and other scientists were ready to pick it up. Fast forward to 1955. Edward Thorpe, a second-year physics graduate student at UCLA, learns about Hibbs and Walford's adventures. Inspired, he decides to try his hand at beating the casinos. But Thorpe faces a new challenge. The roulette wheels no longer have discernible defects. He needs a new strategy. So Thorpe's eureka moment comes when he realizes that the key isn't in the wheel itself, but in the physics of the spinning ball. If he could accurately measure the initial conditions, the speed of the wheel, the velocity of the ball, he might be able to predict where the ball would land. But these calculations needed to make this prediction are too complex to do in your head in the few seconds before betting closes, don't you think? That's why Thorpe needed a computer, a small, wearable computer that can make these calculations in real time. But where could you find one of those? Remember, we're talking about the late 1950s here. The idea of a wearable computer was just nonsense. But Thorpe was determined. He built a prototype and began testing his methods. In the late 1950s, Thorpe took a position at MIT where he met Claude Shannon. Shannon, known as the father of information theory, was intrigued by Thorpe's work, and together they joined forces. By 1961, Thorpe and Shannon had built the world's first wearable computer. It was about the size of a pack of cigarettes and could fit into the bottom of a specially designed shoe. Impressive, right? Wait until you hear how it worked. The person wearing the shoe computer would stand near the roulette table, pretending to be a casual observer. As the wheel spun and the ball was launched, they would use toe switches to input timing data for both the wheel and the ball. The tiny computer would then calculate the most likely outcome and transmit that information as musical tones to an earpiece worn by a second person, the one actually placing the bets. It was ingenious, it was daring, and most importantly, it worked. For several years, Thorpe and Shannon, along with their wives because they weren't going to be left out, tested their system in Las Vegas casinos. They faced some challenges. They couldn't always place late bets without arousing suspicion, so they had to mix their calculated bets with random ones. This made it harder to turn a consistent profit. Eventually, in 1966, Thorpe decided to publish their methods, and so the era of the shoe computer had come to an end, but it had paved the way for even more ambitious attempts to beat the house. So, from that, our story now jumps to the 1970s, where we meet a group of UC Santa Cruz graduate students led by J. Doyne Farmer and Norman Packard. But these weren't any typical academics. Instead, they were part of the counterculture movement, with long hair and all the rebellious mood. They called themselves the Eudemons, after a Greek ethical system based on listening to the good voice inside your head. And they're not talking about being schizophrenic. The Eudemons were determined to take Thorpe and Shannon's work to the next level. Farmer designed an even more compact shoe computer with a new and innovative processor and easy-to-operate toe switches. But they made one crucial improvement. Instead of using sound to communicate the prediction, their computer would send a direct signal to part of the foot, much like the vibrating mechanisms in modern phones. Their system was incredibly effective. The group estimated they could achieve a 44% profit on each dollar bet, a massive advantage over the casino's usual edge. But the thing is, the Eudemons weren't just in it for the money. They saw their project as a scientific endeavor, a way to understand complex systems and chaos theory. In fact, many of them went on to have successful careers in these fields. Casinos, however, were catching on. By the mid-1980s, they had once again upgraded their equipment and explicitly prohibited the use of computers. The golden age of physics-based roulette prediction seemed to be over. But was it really? Fast forward to today, and the question is the same. With our modern technology, could we still use physics to beat the odds at roulette? The answer is maybe. Our understanding of the physics behind roulette hasn't changed much since Hibbs and Walford's day. We know that the movement of the ball and wheel is governed by Newton's laws of motion. We can predict with reasonable accuracy when the ball will leave the rim of the wheel. The challenge lies in predicting where it will end up after it starts bouncing around. Modern roulette wheels are designed to introduce as much randomness as possible. The size of the frets between numbers, the diamond-shaped obstacles that the ball encounters, all these features are meant to make the ball's final resting place unpredictable. But, there's always a but. You don't need to predict the exact number to gain an advantage. If you can narrow down which area of the wheel the ball will land in, you can still gain a massive edge over the casino, potentially more than 40%. And a 40% is much better than nothing, don't you think? So, could we do it today? Well, technology has certainly evolved. All the processing power that Thorpe and Shannon crammed into a shoe could now fit into a smartphone. You could theoretically create a system where a camera videos the ball and wheel, image processing software extracts the relevant data, and prediction software calculates the likely landing area. But to be honest, it's still a bit more difficult than that. First and foremost, casinos are much more vigilant now. They're unlikely to let you point a camera at the roulette wheel, especially if you start winning consistently. Even if you could disguise your system, say using specially designed glasses with a hidden camera, you'd still need a way to input data and receive predictions without arousing suspicion. Then there's the legal aspect. cheating is illegal, and in many jurisdictions, using such devices is seen as a criminal practice. And even if it's not explicitly against the law, casinos reserve the right to refuse service to anyone they suspect of cheating. So, while it may be technically possible to use physics to beat roulette today, the practical and legal challenges make it a risky proposition. Now, there's a twist in our tale. Some researchers argue that you don't need an elaborate computer system to gain an edge at roulette. In 2012, Michael Small from the University of Western Australia published a paper in the journal Chaos, demonstrating a simpler method. His approach relies on knowing the initial position, velocity, and acceleration of the ball. With this information, you can narrow down where it's likely to land, increasing your odds of winning. Small developed another shoe computer that could record every time the ball passed a certain point on the wheel. This data could be used to predict when the ball would start bouncing and which group of numbers it would likely end up in. Using this method, Small demonstrated an expected return of at least 18%, far better than the usual negative 2.7% a player can expect with random betting. This means that for every dollar bet, you'd get $1.18 back on average instead of 97.3 cents. But it's important to note that Small's research was purely academic, if you know what I mean. He wasn't advocating for people to try this in real casinos, so don't try to violate casino rules. Now, where does this leave us? Can physics really help us beat the odds at roulette? The short answer, yes, in theory. The long answer, it's complicated. From a purely scientific standpoint, roulette is not truly random. It's a physical system governed by knowable laws. With enough information and computing power, it is possible to predict the outcome with better than random accuracy. But casinos aren't in the business of making it easy for players to win, right? So don't expect to walk away from them with your pockets full. When it comes to roulette, the house might not always win, but it usually does. And that, perhaps, is the most predictable outcome of all. Play it safe, and you know what to do. Like, comment, and subscribe to the channel. See you in the next video.